Howdy. In this video what we're going to do is we're going to start a 4-part series dealing with logs and exponential. And in this first part what I want to do is I want to talk about the properties of logs as well as how to simplify and to expand them. Okay. Now what I need y'all to have written down is go ahead, jot down these 3 properties. We'll talk about the difference between a log and a natural log, and then we'll practice expanding and simplifying. Okay, now these 3 properties right here, you got to be fluent with, okay? These need to become second nature. Now, whenever you're adding 2 natural logs together, you can combine them as one natural log and multiply the insides. If you're subtracting natural logs, you'll divide, and whichever one has a negative, you're going to put on bottom. And a negative in front of it, you're going to end up putting on bottom. And then finally, this third property, if you have anything multiplied in front of that natural log, you can go ahead and take this constant in front and just raise it to the top. It doesn't have to be a constant, it could be a function too. Okay? Another thing you need to be aware of with these properties is that they go both ways. If you need to expand a natural log, if you have things multiplied on the inside, you can split it into 2 separate and so forth. Okay? So let's run through an example. Let's say I want to expand this following problem. So I'm going to expand the natural log of a squared b over c cubed. Now all of these problems are going to be 2 steps every single time. And the first step is to apply these first 2 properties. What's going to happen is if I want to expand the natural log of a squared b over c cubed, whatever is being multiplied on top, whenever you split them, you add them. And whatever is on bottom, whenever you split that, you're going to subtract. And so that's always your first step. And then in your last step, what you're going to do is any exponent that you have here, you're going to go ahead and swing it to the front. And that's exactly what I'm going to do with this problem right here. So this a squared, that 2 we're going to swing to the front, that 3 we're going to swing to the front. And so your final answer is going to be 2 times the natural log of a plus ln of b minus, and then 3 ln of c. And so whenever we're expanding logs and natural logs, always that 2-step process. Now, you also may be asked, you'll be given a string of natural logs or logs, and you'll want to put it together and combine them as one. So let's take a look at this problem. What I want to do is I have 1/2 ln of x plus b ln of y minus c ln of z minus the ln of x squared plus 1, and I want to write this as a single log. In essence, what I'm going to do is I'm going to reverse engineer it. Whenever I was expanding, I used these first 2 properties first, and then I dropped the exponents. Whenever you're combining, you're just going to reverse that order. The first thing I'm going to do is anything in front, I'm going to go ahead and raise it to the top. And then, so let's go ahead for 1 step at a time. And so that's all I'm doing here. That 1/2 raised into the top, that b raising it to the top, that c raising it to the top, and then the ln of x squared plus 1, well, that's cool. It's just chilling out. Once you have that, the last thing you do is apply these first 2 properties. When you combine it into one natural log, whatever has a positive in front of it is going to be up in the numerator. Whatever has a negative in front of it, right, is going to be in the denominator. It's going to be on bottom. And so your final answer, whenever you're simplifying this into 1, is this x to the 1/2 and y to the b, that's up top because they're positive. Now, I changed this x to the 1/2 to square root of x. It's the same thing. You could have left it as x to the 1/2. That's more than okay. But this z to the c, as well as this x squared plus 1, had a negative in front. And so because of that, whenever I combine it into one natural log, it went into the denominator. So these 3 properties you got to be fluent with, and the way that you expand and the way that you simplify into one they're both going to be 2-step processes. Okay? And so go ahead, join me in the next video, and we'll talk about how to algebraically solve for x whenever they're all mixed up within logs and natural logs.